Professor Spectrum, experts in spectral technology.
Welcome back to Professor Spectrum. I'm Sophie Shironi and I work at Portable Spectral Services as a spectral analyst.
And I'm Naomi Potter and I work as a spectral geologist. And today we'll be answering some of the most Googled questions about Raman spectroscopy.
Here at Portable Spectral Services we have a handheld Brooker Bravo Raman. It's fantastic for in-field handheld analysis for mineral identification.
Alright, let's get started. How does Raman spectroscopy work?
Okay, so Raman spectroscopy works by, it's also a light technique, but it differs from things such as near-infrared and FTIR analysis because instead of basically taking a full light range and directing that at the sample and looking which wavelengths actually get absorbed by the sample, in this case for Raman spectroscopy it uses a monochromatic beam, so light at a single energy. So that energy is directed down onto the sample, and when it hits the sample it actually polarizes within the bonds, actually in the compounds or minerals. And when it does that, it changes the energy of the beam. So Raman spectroscopy is actually looking in the change of energy of that incident beam. So it's a little bit different to our standard FTIR and near-infrared techniques. It fundamentally, though, of course, is still a structural technique. You're not looking at your elements that is actually the chemistry of your sample, but rather the actual structural components.
What is Raman spectroscopy?
Well, contrary to how many questions I actually get, it's got nothing to do with ramen noodles. So Raman spectroscopy is, well, for starters, it's spelled slightly differently. It's R-A-M-A-N, not E-N. But Raman spectroscopy is named after the fact that the technique actually measures Raman scattering, and that specific type of light scattering was initially discovered by an Indian man whose name was Raman. So that's where the name actually comes from. So sadly, nothing to do with the noodles.
What is the difference between infrared and Raman?
So actually fundamentally they both analyse the vibrations of structural bonds within a sample. The types of vibrations they actually measure are slightly different. So you can look between bonds that have dipole moments versus polarising bonds. So they're actually very commonly used as complementary techniques. So if you really want to completely characterise the structure of a compound or sample, you can use both IR and Raman. So some bonds are only Raman active, some bonds are only infrared active, and that really gives you then your complete comprehensive analysis of a compound structure.
Is Raman spectroscopy destructive?
No, as a general rule. In some cases there are arguments that under long beam times with higher energy beams you can cause very minor structural deterioration of a sample, but as a general rule from most people's perspectives, Raman is not a destructive technique at all. It just uses effectively a visible laser light.
Is it better to analyse pure samples or pulps, or does it not make much of a difference?
Pulps can cause a little bit more of a challenge in some ways because you have that granulation of the sample that provides a rough surface. You get a lot of scattering of light just based on the topography of the sample. So it can make your spectrum a bit noisier. As a general rule, solid samples give better quality spectra, but it can still be done. Okay.
Is Raman spectroscopy quantitative?
Again, this is a little bit of a contentious area. In theory, it's same as something like FTIR. The peaks of the spectrum can be directly proportional to concentration. However, one of the things that can impact a Raman spectrum is the crystallinity of a sample. So if you've got a sample that has a very defined crystal structure, analysing it from one orientation on the crystal versus the other orientation on the crystal can actually impact the intensities of different peaks. As such, particularly in the mineral space, that makes quantifying, say, mineral structures very, very difficult. It'd be great if someone could figure it out. Unfortunately, this is still quite a contentious area of different techniques that are being used, particularly in the geoscience space, of seeing if we can quantify Raman data. Primarily, it's generally used for qualitative analysis still, though.
Yeah. Which laser is used in Raman spectroscopy?
Okay, so you can actually, there's not necessarily just one laser that can be used. There are multiple lasers that are used basically to, depending on what type of sample you're analysing, to optimise it. Same thing for something like portable XRF, you optimize your beam depending on what elements you want to analyze. In Raman, you can choose your laser energy based on what type of sample you want to analyze. In the Brooker Bravo instrument we actually have in-house as a handheld Raman, it actually has a dual laser system, which is very, very useful. So it can implement 2 different laser beams in the same instrument, which gives you a great broad range of analysis. Along with it actually helps with noise reduction as well. So that's one of the great benefits of that particular model as well.
Thanks for watching everyone. I'm Naomi.
And I'm Sophie.
And we'll see you next time.